My name is Sarah Broninger of the New Horizons Academy, and I've been asked, when should students memorize what parts of math? And the answer is simply this. When you're looking at memory versus understanding, you're really looking at facts versus doingness. You memorize a fact because you can't understand it. That's your reason for memorizing, which leads you to think that memorizing is the solution to a problem of I can't understand this. You memorize a phone number because there's no understanding to a phone number. It's completely arbitrary. You memorize the alphabet because that sequence is completely arbitrary. We could have chosen to put the alphabet in any sequence. When you're learning math and you're in school and you've been taught this whole new formula, you've been taught the Pythagorean theorem, and you don't get why is it a squared plus b squared is c squared. You don't know, so you memorize it. Most people have that one down. They have no idea why, so it's memorized. The way math is taught right now in America is like 90% memory and 10% understanding. And it shouldn't even just be the other way. It should be 95% understanding and like 5% memory. There are a few things you do need to memorize. Things like things that add up to 10. That's a great thing to memorize. You can actually understand almost all of your times tables. You don't actually have to memorize your times tables, but after a while, you kind of just get them memorized because they are facts. And that is your key. Is it a fact? Memorize it. Is there a doingness? Is it a formula? Does something happen? Then you have to understand it, not memorize it. Because if you understand why something works, well, then you can choose when to do it. And that's the crux of it. You get onto life, let alone life, you get onto the SAT and you're given all of these word problems and students fall flat on their faces because you can give them pages and pages and pages of formulas and they can do it because they're good little robots and they have been told and drilled and drilled and drilled on how to use these formulas, but they have no idea when to use the formulas. And the only way you can choose which formula to use is if you understand them. That is why I cannot go to my calculator and take a common SAT problem. I grabbed an SAT problem. Can you see it?
Yeah, it's perfect.
I grabbed an SAT problem. Plug that in your calculator. Go ahead. Why? Why won't that work? It won't work because the calculator is full of facts. It is not a human. It doesn't understand why. So if you treat your student like a calculator and plug their head full of facts and then expect them to go into the workforce and apply this math to make their business expanded, it's a joke. Because they'll say, give me a page of problems, I can do it. But you have to figure out what the problems are. No. You should be able to use math like this. This is a linear equation. You did them in high school. You did them in college. You probably did thousands of them, but you probably look at this problem and don't remember how to do it because the why was missing, so you don't know what math to choose to solve it. It's actually a simple problem. A pediatrician uses the model above, this math above, to estimate the height of a boy, his height, in terms of his age, here's his age, in years. Based on this formula, what is the estimated increase of a boy's height each year? This is simple math, very usable in business. This is just saying, if a boy comes in and he's 3 years old, how tall should he be? What should his height be at 3 years old? Well, it would be 3 times 3 is 9 plus 28.6 inches. That's how tall he should be. He should be this plus, should be like 37 inches. It's usable math. Now, understanding how this works is different from the gazillions of pages of linear equations you did in your math book, which was all just dry formulas. This is actually being used in life by some doctor's office. And this number right here is the slope. This number right here tells you how steep the graph is. And if in 1 year it goes up 3 inches, then the estimated increase each year of a boy is 3. And it's that easy and there's no math involved because I understand this problem. So on the SAT, they give you multiple choices. You can plug all those numbers in and spend a good 7 or 8 minutes of your SAT trying to figure out the answer, or you could actually understand how a linear equation is used in life. There is a reason that business math is part of every business degree program. You can actually do well in your business if you can apply math to your business. So when you get a kid who gets to his SATs and they can't choose which problem to do, it's because they don't know why that formula creates that kind of answer. So they have treated all their math, and it's not their fault because it's how they've been taught to do it. They have treated all of their math as facts instead of doingnesses. They've memorized everything, but there's no magic memory pill that tells you when you use what math. There's no avoiding it. You have to understand the math, or you can't choose what math to use. I hope this helps.